So our goal today, right, is to take this. Whoops, frozen. Our goal today is to take that quadratic right there, that quadratic equation, all right, and we want to solve it by factoring. Okay, there's more than one way to solve a quadratic equation, multiple strategies. Okay, one strategy that we'll be using is factoring because it can be easier or faster than some of the other methods. Okay, and so that's why we kind of learn this way too. And it's going to be a helpful skill we'll be using later on in this class too. We talk about other polynomials too. It's just the factoring idea. Okay, so let me talk really briefly about factoring. So factoring can mean, factoring. Well, I don't even know if I'm going to write anything, but factoring can mean, a lot of different strategies. There's ways that we factor, right? So, for example, the primary way that we factor is by using GCF, greatest common factor, right? That should be something you should always look for first. But then we also will be using a skill like we're going to show you right here with factoring, these quadratics and stuff like that. Okay. Specifically quadratics of this form where our a, remember this is in standard form right here, our a is what number here? What number is our a in this standard form? 1, right? A is 1. There is no number there, so we can assume it's 1, okay? So today we'll focus on factoring with just a when a is 1, when our leading coefficient is 1. And then tomorrow we'll look at factoring when our leading coefficient is not 1, okay? I was going to try and squeeze in both today, but I just was like, it started to feel kind of tight. So we'll hold off on that. Okay, so if x squared plus bx plus c factors, okay, it will factor to the form x plus m times x plus n. All right. So if we're going to go to factor x squared plus bx plus c, we know it will have to factor to the form x plus m is equal to x plus n. Okay. The trick is figuring out what that m and what that n are. Okay? So another way to say this is that we want to get something like this, right? We are going to be given something, a quadratic in this format. We want it to be equal to something here. This is in factored form, right? It's factored. Two different things broken apart there. Okay. Now, we can use this idea to kind of help us make some clues about how we're going to factor the original function here. So let's FOIL this out. Okay, so x times x will be x squared. Right? That's the x times the x there. Okay, just like we did in the warm-up. X times the n, okay, well that will be nx. N times x, right, nx. And then we'll do m times the x. So that's mx. And then m times the n, mn. Okay? Now, we do one more little step here. These two right here are like terms, right? The nx and the mx. Right? They both have an x. So I'm going to factor this x out. And what else I like that? Okay. And now if you look here, we kind of have our standard form. Right? So we said that if this thing factors, it'll factor to something in this form. All right, but if I multiply this out, we get this. Okay. what does the n plus m correspond or match to in our original quadratic right here?
B.
The b, right? N plus m, that's the number in front of the x. The b is the number in front of the x. So in other words, b is equal to n plus m. Okay? Maybe I'll put that, kind of highlight that with some red here or something like that. So, What does mn correspond to from our original here?
C.
C, right? It's a constant, right? M times n is going to be a constant. There's no x with it. C is the only part of this that doesn't have an x with it, so it's also the constant, right? So then the C corresponds to the mn. So in other words, C is equal to m times n. And just like that. So this is just another way of seeing, that relationship, that strategy about how we factor a given quadratic. Right? That's just another way that we do that. Okay. So let's do an actual example here, right? So let's just say we want to factor x squared plus 3x minus 12. Okay. And so we know that if this thing is going to factor, it will factor to two binomials, right? We'll have to have an x and an x, because the x times the x will make that x squared. And then we got to figure out our m and our n. Okay. And if we just look at what we did right up here, right? N plus m, right? If we add these two numbers together, these two numbers have to add to make what in this particular case? What's our b? 3, right? So the two numbers here, they're going to have to add to make 3. So I'll write that over here. So m plus n has to equal 3. And they multiply to what? Negative 12. Okay? And again, this is not some sort of strange thing, right? This shouldn't be some sort of strange, like, whoa, where's this weird thing? I mean, imagine this polynomial, or imagine these two binomials here. If I were to multiply these two things back together, I would have x times x, there's the x squared. I would have this x times n, and I would have this m times this x. So in other words, these two numbers here, they would combine together to give me that 3, right? And then the last, the L of FOIL, right, would be m times n, and that gives us our constant there, negative 12. So m times n has to be negative 12. So this is not like mathemagic here, right? It's just like what we would have to do to get back to the original problem here. Okay, that's all. So this is where we have to use our brain to kind of like almost guess and check. This is what I would call the guess and check method, right? Where we're just kind of trying to think of two numbers that multiply to negative 12 and add to make 3. What are those two numbers? What are those two numbers? Plus 3x minus 12. Did I pick an impossible problem?
Yeah.
I did. I did pick an impossible one. Okay? I'm sorry about that. I did not mean to pick an impossible one for the first one. All right. So this one doesn't work. There's no two numbers that multiply to make negative 12 and add to make 3. Okay? So, and this is going to happen to you guys too, which is a really frustrating part because you'll never know, or sometimes you'll be at this like weird place where you're like, well, I think there's no solution, but then you'll question, but did I check every single possibility? Maybe I missed something, right? So that really makes it frustrating, whenever your teacher puts that like multiple choice, but like letter D is none of the above, and you're like, oh crap, you know, it could be letter D and that covers everything. Anyway, so let me do another one here that actually works. My apologies there. All right, this one will factor. So again, we want two numbers that add to -9, but that multiply to 20 here. So take 30 seconds. All right, think about what two numbers multiply to 20 adds -7. -9. Can't read my own handwriting. There we go. Multiply to 20 adds -9. All right, Jonathan, you got an answer for us?
-5, -4.
-5, -4. Let's see here. Claire, do you agree? -5, -4?
Yeah, I just said -4, -5.
Ooh. Does that matter? No, it doesn't. The order doesn't matter. So you can say -4, -5, -5, -4. That's okay. Okay, so yeah, -5, -4. Let's check it out, right? -5 times -4, positive 20. -5 plus -4, -9. And so there's our answer right there. That's factored. Okay, so that one did factor. Okay. We'll talk later about these impossible ones and what to do with those. We're not going to just be done with them, but for now we will. Okay, if it doesn't factor, we'll say it doesn't factor. Okay, so here, you guys try one. Let's do x squared minus 3x minus 18. Okay, so again, factor of the directions there.
Well, what do you like mathematical? So there is a formula you can use to solve algebra, but as far as like, can you avoid guessing and checking? Kind of, but not really. All of ours is some sort of guessing and checking. Well, there is.
In our prize box.
That's what we could be able to use too. But you
Never
also
got one
want
of
to go back
those.
as well, because factoring so there is a function called do you have trouble with math already? Why? Because so I mean you'll get faster at it. If you maybe were still a bad guesser, but it's not but yes, but you'll get better at it when you practice. So how do you what strategy do you use? I was what do you yes. Well, but you want to see nice numbers. So like 2 and -9.
Yeah, they are.
Right? Or this was 6 bucks.
Yeah.
Okay.
Yeah.
30 seconds.
Yeah, that's right.
All right, Allie, you got an answer for us?
Yes, I do.
What is it, please?
-6 and +3.
Okay, so the final answer would be then x minus 6, x plus 3 is what you're saying?
Yeah.
Okay. There it is. That's it. Okay? There should never be a question in your mind, in a problem like this, there should never be a question in your mind, did I get this right? Because all you got to do is just multiply this back out. Imagine multiplying this back out, you should get exactly this. Right? So when you factor this, it goes to this, and if you multiply this back out, it should give you that. Okay? Ash was trying to ask if there's an easy way to do this, and the answer is not really. Okay, it is kind of a matter of guessing check. You will get better at it the more you practice it. Okay, I would always encourage you to start with, and you probably maybe this is basic to you, I don't know, but I mean always start with looking for numbers that multiply to this. Think of the two numbers that multiply to make this, and then check to see if they add to make -3. Don't try to think of numbers that add to -3 and then check to see if they multiply to make -18. I think that's going to be more work, right? There's way more numbers that add to make -3 than that multiply to make -18. At least nice numbers, we'll say, right? Nice numbers. So, all right. Questions on any of that? And of course, always remember there is the option of it might not factor too. Okay, so keep that in mind as well. All right. Questions on any of that? All right. So of course, there's like special cases and things. We're going to talk about those too. So we'll talk about difference of squares. And also perfect squares too. Okay, so for example, difference of squares, the classic formula here. Off the screen, sorry. Okay. Again, we're not very creative in our naming in math, right? When we see a difference, right, subtraction of two perfect squares, we call that a difference of squares. Wow. All right. This will always factor to the form a plus b, a minus b. Do you need to memorize this formula? Not really, because you can kind of factor a lot of stuff with our normal subtracting strategies, but it's helpful to just have it down there. Okay. And then the perfect squares. And again, you don't necessarily need to memorize these formulas because we'll be able to factor these, kind of like using our normal strategy I was just showing you, okay? But it is helpful to just kind of talk about these, okay? So for example, I'll just show you an example of each one here. So here's an example. Let's do like x squared minus 49. Okay. Is this a difference? It's a subtraction, right? Difference. Are these both perfect squares?
Yeah.
Yes. 49 is the square of 7, right? X is, x squared is just x squared, right? So we can kind of do this two ways, all right? Let me show you this way here using our difference of squares formula, just to show that works. So this is just x squared minus 7 squared, like that. Right? So in other words, our A would correspond with what in here? A corresponds to x, and the B corresponds to 7, right? And so we can just use this form right here. Okay, so if A is the x, then I have x plus my B of 7, and then x minus my B of 7. There it is. Okay, no guessing and checking required. We recognize it was perfect. Our difference of squares, we use difference of squares formula. However, if you're anything like me, right, I hated memorizing. Ugh, it's the worst. So you can also just factor this. Okay? What's our b term here? 0, right? We don't have a b term. We have our a, right? Ax squared, right? So it's 1x squared. We have our c, it's the minus 49. So if you want to, you can take this difference of squares and make it like a plus 0x if you want in the middle there. Okay? And if we use our previous strategy, that means we're looking for two numbers that multiply to negative 49 and add to make what? 0. So what two numbers multiply to negative 49, but also add to make 0? 7 and negative 7. Okay. No difference of squares formula necessary. Okay. Just recognize when you see this, right, that your b is 0. So you need two numbers that multiply to the c, negative 49, right, negative 7 and positive 7, and they add to make 0 as well. That's it. So you don't need to memorize that difference of squares formula. It can be helpful to know, though. So I mean, I wouldn't just like completely forget about it, but you can get around it by just factoring like normal. Likewise here. Okay. So, I mean, for example, d squared plus 12d plus 36. Okay, in fact, I'm not even going to bother using the formula here because I just think it's too much. Okay, in this case, we're looking for two numbers that multiply to make 36 and add to make 12. Okay, so what two numbers multiply to 36, add to make 12? Yeah, 6 and a 6 again. And you can see, whoa, we have the same factor. When you multiply something by itself, it's the same thing as that thing squared. Right? So you can leave it d plus 6 times d plus 6. That's fine. But really, remember, it's the same thing as d plus 6 squared. Right? So that makes this, that means, in other words, this is a perfect square. Kind of weird to think about, right? Numbers are perfect squares, right? 4, 9, 16, 25, 36. Those are perfect squares. This polynomial is a perfect square because it's d plus 6 times d plus 6. Questions on any of that? Thoroughly confused yet? Give up? No? No? Not yet? All right. Maybe? No? Michael, you're hanging in there?
Yeah.
All right. Claire, is he really, or is he just saying yeah? Hard to read. Yeah, I know. It is hard to read. Try being a teacher. I got 30 of you have to try and read. All right. 35. Well, 33. Okay. But, Mr. Witt, you did not say that we were just factoring today. We are solving an equation by factoring. We have not solved any equations yet. All we've done is taken an expression and factored it. Expression and factored it. Expression and factored it. How do we actually solve an equation with this stuff? Well, that's a good question. Okay. So, before we talk about solving the equations, let's talk about the zero product property. Review that. Okay. This is the crux of solving every quadratic equation by factoring it is. Okay. We're going to be using this property into other units as well, so don't forget about it. This is crucial. Okay. If the product of two numbers is 0, then one or both of those two numbers must be still thinking about it, okay. I hear it, yeah. If the product of two numbers is 0, so if you have two things that are multiplying, and it doesn't have to be numbers, I could just write expressions there. If two things multiply and their product is 0, one or both of those two things must be 0. Must be 0. There's no way to get 0 without multiplying by 0 in the first place, right? You have to have times 0 in the first place. How does that help us, Mr. Wiz? Well, we just did it, right? Is this a product? Is this two things multiplied together here?
Yes.
Not written out yet like that. We can make it a product though, right? How can we make, what is this a product of? We just did it in our example, right? In our, the one you guys tried. What is this a product of? X, what? Minus 6 and x plus 3, right? Equals 0. So this is the same as this. Now we have a product of two things. 1, 2, right? Two things that multiply and they give us 0. So if the product of two numbers, or really two expressions, is 0, then one or both of the two numbers must be 0. So in other words, this must be 0, or x plus 3 must equal 0. And so we get x is 6 and x is negative 3. But Mr. Witt, we've solved equations before. We didn't have to do factoring, right? When we solve equations, can't I just get the x by itself here? Well, can you get x by itself here? So the answer is we can get x by itself here, but we're either going to have to get the x by itself, and so we'll have x squared on the other side, or we get the x squared by itself, and then we'll have x on the other side, right? There's no way we can get just the x completely by itself here. So in other words, we have to do some sort of way, we have to use some sort of method here that allows us to then break these things up. And so factoring into these two factors, right, allows us to split this up into two simpler equations like that, and then solve. Okay? So that zero product property is huge. Very important. Okay? Very important. Okay? So let's see here. Can I do something without messing this up? All right, let's take a look at another one. Okay. Oh, Mr. Wood. Easy. Okay, let's see here. We need two numbers that multiply to 6 but add to make negative 5. So let's see here. Two numbers that multiply to 6 would be, oh, I know, negative 2, negative 3. Okay, let's see. Does that work? Negative 2 times negative 3 is positive 6. Negative 2x and minus 3x, that'll make them minus 5. So, yep, that checks out. That would factor, this factors to this. Okay. And so now let's see, I have two things that multiply and they're equal to 42. So x minus 2 equals 42, x minus 3 equals 42. Right? No. This way, you're the worst. I know, I am. Okay, this is wrong. What did I do wrong?
Everything.
The numbers have to multiply. The products of x minus 2 and x minus 3 have to equal 42, so only one of them should equal 42.
Well, so I hear what you're saying. Yeah. You're on the right track there. When you multiply two things and their product is 42, okay? So Evan was saying, you can't have both of these things be 42 because then it'd be 42 times 42 and it wouldn't be 42, right? Okay. when two things multiply and their product is 42, do one of those things have to be 42? So what's a way we can multiply to get 42? Like 6 times 7, right? Is 21 and 2. Do either of are those equal to 42? So in other words, when I have a product and it's equal to 42, do either of these two have to equal 42? The answer is no. It could be 6 and 7. It could be 2 and 21. What is my error here? What must I be equal to?
0.
Yeah, you got to be equal to 0. Okay, you must equal 0. You must equal 0. So this initial step, even though Mr. Weighted factors, I know it does, but it's not equal to 0. Only 0 has the 0 product property. So we have to start over here. Okay, and what should be my actual first step? Not factoring. What should be my first step? I want it to equal 0, right? What do I need to do?
Minus 42.
Yeah, subtract 42. Move that 42 over, right? And then that gives me a minus 36 equals 0. Now can I factor? Yes. So, must equal 0 to solve by factoring. Okay. It's classic student error. And that was even more tricky because it factored. Right? And you're like, oh, that's really nice. No, it must be equal to 0 first. So now we will factor. We need two numbers that multiply negative 36 and add to make negative 5. Yeah, negative 9, positive 4. Okay? And then when you solve, you have x minus 9 equals 0 and x plus 4 equals 0. So then we get x is 9 and x is negative 4. Okay. But yeah, Evelyn, that was some good reasoning too. That was good there too. Okay. All right. So you must equal 0. Must equal 0. Okay. All right, I got one more problem for you here, and then we'll cut you loose on the assignment. Okay, I got one more for you here. Oh, and I'm going to have quite enough room. I'll have to go to the next page. Shoot. All right. So a town has a nature preserve with a rectangular field measuring 600 meters by 400 meters. The town wants to double the area of the field by adding land as shown below. And I'll draw a picture here. Find the new dimensions of the field. Okay. So one more. A town has a nature preserve with a rectangular field measuring 600 meters by 400 meters. The town wants to double the area of the field by adding land as shown below. I'll show you the picture here. And we're going to find the new dimensions of the field. So here's the original field. We'll say is 400 by 600. Okay, and here's the addition. Or the additional field. Okay, now we're going to add in this way. So we're going to add like X, we're going to expand that field out, further down, further out, further to the left. So we want to find the new dimensions of the field. How can we relate all this information? Right? Well, remember, our goal is we want to double the area of the field. We want to double the area of the field. So, what is double the area of the original field going to be? So Max, yeah?
4,800 square feet.
Yeah, so 400 times 600, right, will be 240,000, yeah, and so then 480,000. So, yeah, so it'll be, yeah. So 400 times 600, that's the original area of the field, and we want to double that, so it's going to be 2 times 400 times 600. Okay, that's going to be our new area. Okay, and that's going to equal, what are the new dimensions for this field going to be? The original field was 400 by 600. What will the new dimensions of the field be? Instead of 400, what will be the new width of that field, we'll say? What can we write? As an expression. So something with a variable in it, right? 400 plus x, right? 400 plus the extra x that's going out. Okay. And what will be the length of that field? Instead of 600, it'll be what?
600 plus x.
Yeah, 600 plus the x. Exactly right. Okay. And so we would multiply this all out, right? So we multiply that out, we get 480,000. Okay, we multiply this out, we'll get x squared plus 1,000x plus 240,000. Okay. And to solve this, we need to make sure our quadratic is equal to what value? Whenever we solve a quadratic equation, we want to make sure it's equal to 0, right? So I got to subtract this 480 over 240 minus 480 is going to be minus 240,000. Okay. So we want to know when this is equal to 0. So we can factor it. All right. These numbers are rather large to factor and stuff like that. Okay, I don't think I'd give you something quite this awful, without a calculator or anything like that. But it does factor, believe it or not. Okay, it factors to x plus 1,200, x minus 200. Okay, and then we'll just solve, right? So we get x equals negative 1,200, and we get x equals 200. Okay, so question?
Yeah, how from...
1 second. Hello? Hi. Yes. I think so, yes. Yeah. Okay, gotcha. Okay. Do you want to give Socash a call and just see if we can split his class maybe or something? Or I can talk to him real quick between classes too. Oh, gotcha. Oh, okay. Okay, then just send it to me. That's fine. Yep. You're welcome. Bye. Okay. So anyway, now your question.
Yeah. Before you had 1,600x. How did you get from 1,600 to 1,000x?
Because I think I made an error. That was supposed to be 1,000, and it's pretty sloppy. It's 1,000. That's what that is. Yeah. Sorry about that. That is 1,000. Okay. So, do both of these answers make sense in the context? No. Which one does not make sense? The negative one, right? Because we wouldn't add negative 1,200 to a 600 long, field that would make a negative dimension. So that one's right out. Okay. But our final answer is not 200. Remember, we want to find the new dimensions of the field. So the new dimensions will be, what will this new dimension be?
600.
Yeah, 600 by meters by, and what's this new dimension going to be? 800 meters. That's right. Okay, so there it is right there. Okay. All right. Very good. So let me give you guys your assignment then. Okay. So again, this will be in the green book. I have not posted this PDF yet, so we'll just get it to you here though to get started, and then I'll post all that stuff. So again, we're still in the green book, section 4.3. Okay, page 255 is where it's going to start. Goodness. All right, let's have you do numbers 9, 12, 15, 21. 24 and 27. 44. I'll do one more. 67. Okay. So there's the assignment. Let me quickly post this onto Schoology and stuff like that. Sorry about my delay here.